This is a revision tutorial for OCR Gateway Physics. In it we'll be looking at a topic from P1A, specific heat capacity. So that last section was for higher tier only. This section is again for foundation and higher. We're going to think next about heating things up and what the energy needed to change the temperature of an object, so the energy that you need to heat something up, what does that depend on? Well, it actually depends on three things. It depends on the mass of the object, it depends on how much you want to heat it up by, so the temperature change, and it depends on something called the specific heat capacity of an object. The specific heat capacity is a property of the material that is being heated, and it depends on how easy or how hard it is to heat that material up. So a substance which has a high specific heat capacity will take a long time to heat up and cool down. Substances which have a lower specific heat capacity are much easier to heat and cool. Okay, this is the equation that you can use to calculate the energy that it is required to heat something up, or the energy that's released when something cools down. This will be on the front page of your exam booklet. So don't forget, whenever you see a question where you're going to need to do a calculation, always go there first and find out the equation that you're going to need. You'll be given this equation, but you won't be given the units. So let's go through the standard units for each of these. Energy is measured in joules. Now mass is a slightly unusual one. Remember, mass, the standard unit for mass is kilograms, not grams. The temperature change is going to be measured in degrees Celsius. Specific heat capacity, joules per kilogram per degree Celsius. We've got an example here of applying that equation. So we're asked to calculate the energy required to heat 0.3 kilograms of water from 20 degrees C to 100 degrees C. And we're given the specific heat capacity of water, which is 4,200 joules per kilogram per degree C. So we've gone to the front of our exam paper, we've worked out the equation that we're going to use, and the first thing that we always do is write out that equation. Now I'm going to write symbols for short, so we're going to have the energy equals the mass times the specific heat capacity times the change in temperature. Now this triangle here, in case you haven't seen that before, is just a shorthand way of writing change in. Now the next thing we do is substitute in our values. So underneath we can write in the value for the mass, which is 0.3 kilograms. We now add the value for specific heat capacity, which we're told here is 4,200. And we can now add the change in temperature. Now the temperature is rising from 20 up to 100, so the change in temperature is 80 degrees Celsius. Now is the time to get your calculator out. Make sure you have one in the exam and plug all those numbers in, and the answer you get is 100,800 joules. If you're studying for the higher tier, you might be asked to use this equation to calculate something other than the energy. So you might be asked, for example, to calculate the change in temperature or the mass or the specific heat capacity. If you're confident about changing the subject of an equation just by looking at the equation, then go ahead and do that. If that is something that you're not confident with, then a method that you can use is a triangle. Now, technically, this equation doesn't quite fit the triangle because we've got more than 3 things in there. We've got 4 things, but we can still fudge it a little bit to make it fit. Now the rules for writing an equation into a triangle are, if 2 things are multiplied in the equation, then they need to be multiplied together in the triangle, and if something is above the line in the equation, it needs to be above the line in the triangle. Okay, the second one's not relevant here, but the first one is. Now we've got 3 things here that are multiplied together, so they need to be multiplied together in a triangle, and that means they need to go at the bottom here. So we're going to have our mass, we're going to have our specific heat capacity, and we're going to have our change in temperature. I've got my triangle there again to say change in at the bottom. Okay. That leaves us with energy, and that's going to be written at the top of our triangle here. Now, to use our triangle, we have to cover up the thing that we're trying to work out. So let's say, for example, we've got a question that asks us to calculate the mass. We want to rearrange our equation so that the mass becomes a subject and we get mass equals. So what we do is we cover up the mass. You can't see me covering it up on here, so I'm just going to cross it out. And what we're left with is the energy divided by specific heat capacity times change in temperature. So I'll write that out over here. Energy divided by specific heat capacity times the change in temperature. We do exactly the same if we wanted to work out the specific heat capacity. So I'll write specific heat capacity over here. Then we come to our triangle, we cover up, or in my case cross out, the thing that we're trying to work out, and see what we're left with. Well, we're left with energy divided by mass times the change in temperature. So let's write that out over here. Specific heat capacity is equal to the energy divided by the mass times the change in temperature. And we can repeat this again for the change in temperature. So if I wanted to calculate the temperature change, I cover that up on my triangle, and I'm left with energy divided by the mass times the specific heat capacity. Let's look at an example of this. 105 kilojoules of energy is needed to raise the temperature of 0.5 kilograms of water by 50 degrees C. Calculate the specific heat capacity of water. Something to notice here before we go any further is the units that we're given for energy. The units in the question are kilojoules. Now, they are not the units that we're going to need if we're going to use our specific heat capacity equation. We are going to need this value in joules, so it's worth looking at these kind of things even before you start. Next thing we do, we go to the front of our exam paper and we look at our list of equations. We then pick out the equation that we need, which is going to be this one. Energy is mass times specific heat capacity times the change in temperature. Now, we'll see that, so you can see that the thing that we are asked to calculate is not the energy. We're given the energy. The thing that we are asked to calculate is the specific heat capacity of the water. So we're going to need to rearrange that equation and change the subject. Let's use our triangle. So don't be afraid to draw this out on your exam paper. Show all your working. It's much better to do that and to get the right answer than to just do it in your head and perhaps make a mistake. So we know that anything that's multiplied together in the equation needs to be multiplied together in the triangle. So that means that mass, specific heat capacity and change in temperature all need to go at the bottom, and that leaves us with energy at the top. The thing that we're trying to calculate is the specific heat capacity. So let's write that out here, then cover it up, and we are left with energy divided by mass times the change in temperature. The next thing we do is substitute in our values. We're told in the question that the energy is 105 kilojoules. 1 kilojoule is 1,000 joules. So our energy is actually 105,000 joules. The mass is 0.5 kilograms, and the change in temperature is 50 degrees Celsius. The order in which you do your timesing and dividing is important. If you've got a scientific calculator, what you need to make sure you do is put brackets around the mass and the temperature change. If you don't have a scientific calculator, you need to work out this bit first and then do 105,000 divided by the answer that you get. Okay, so time to get the calculator out, plug all of that in, and the answer that you should get is 4,200, and that's joules per kilogram per degree C. This slide shows an experiment to measure the energy needed to heat a block of aluminium. We can see the block of aluminium here, and inside there's an immersion heater which is connected to this power supply. There's also a thermometer to measure the change in temperature, and there's a balance so we can find the mass of the aluminium. We'd also need a stopwatch. What we would do, we would measure the temperature before heating the aluminium and then after heating it for a certain amount of time. Down here we've got an example of 5 minutes. We would also need to know the mass of the aluminium and the power supply. We could then work out the energy required to heat it by using the fact that the energy is a power times a time. So if we know the power of the power supply and how long we've heated it for, we can calculate the energy. We could then use this to calculate the specific heat capacity of the aluminium. And to do that, we would need to use our equation that the energy is equal to the mass times the specific heat capacity times by the change in temperature. And if we know the energy, the mass, the change in temperature, we could then calculate the specific heat capacity. And that's it for this section of P1A, specific heat capacity.